Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 7 of 21. Real-world big data is rarely a flat spreadsheet. Sometimes you need an array of nested dictionaries just to parse a single JSON event. To handle that, we need to talk about taming complex and nested data. Relational workflows prefer flat tables, but modern event data arrives heavily nested. PySpark handles this by providing three complex data types. These are ArrayType, StructType, and MapType. These allow you to explicitly model hierarchical structures natively in the engine. Take a standard customer profile to see how these types operate. The first concept is ArrayType. This represents a collection of elements. The strict rule is that every item inside an array type must share the exact same underlying data type. You cannot mix strings and integers within the same array. If your customer profile includes a list of recent order IDs, you define that column as an array type containing integers. Next is StructType. A struct type models a nested hierarchical record, essentially functioning as a row embedded inside another row. It contains specific named fields. Unlike an array, each field inside a struct type can have a completely different data type. Suppose your customer has an address. That address contains a street name as a string, a zip code as an integer, and a Boolean flag indicating if it is a commercial property. You bundle these distinct fields together into one struct type. Here is the key insight. You can nest these complex types arbitrarily deep. If a customer has multiple addresses, you do not create flat numbered columns. Instead, you create an array type where the internal element type is that exact address struct type. You now have an array of structs, which perfectly maps to a standard JSON array of objects. The third structure is MapType, designed specifically for key-value pairs. It differs from a struct type in how it handles structure versus schema. A struct type requires you to hard-code the exact field names up front. A MapType is flexible with its data contents, but strict with its data types. Every key in the map must be of one specific type, and every value must be of another specific type. You might use a map type to store customer application preferences. The keys could be strings, such as theme or language, and the values could also be strings, such as dark or English. Because it is a map type, the upstream application can inject entirely new preference keys later without forcing you to alter the core data frame schema. You simply query the values dynamically by their keys. When you construct this complex schema in your code, you build it from the inside out. First, you define the inner fields of the address struct type. Then, you pass that completed struct into an array type definition. Next, you define the map type for the user preferences. Finally, you wrap all of these components along with simple scalar types like the customer name string into one master struct type that defines the overarching data frame row. Instead of flattening nested structures into messy JSON strings, explicitly defining these complex schemas allows the Spark optimizer to prune data and filter deep within nested fields without deserializing the entire payload into memory. Appreciate you listening. Catch you next time.